Hello everybody. Definitely you want to copy down this entire first slide while I'm kind of explaining what's happening here. So we're going to be finding trig function values with a calculator. This is part 2. Go ahead and put the date and the title, copy down example 1, and then we're going to be finding the value of theta in this interval. So what we're looking for here is an angle. Yesterday, when we looked at these examples, we knew the angle, and what we were finding was the trig function value. Now what we have is the trig function value, and we are looking for the missing angle. According to the directions, this angle will be in the interval between 0 and 90 degrees. So we're going to start by writing out what we're looking for, which is theta. We're trying to find this missing angle. We're going to use the trig function that is given. So that's going to be the tangent. And what you will notice is that since we don't have the angle, you're going to have to do the reverse of that, also known as the inverse. So we're going in the opposite direction. Instead of typing in tangent of some angle equals, we're going to be typing in the value of that trig function, and we're going to put in the inverse. And that will give us our angle approximately. And we're going to round it to 6 decimal places just like we did for the last lesson. So the inverse of the tangent, if you look at the calculator, you will see sine, cosine, and tangent. The inverse of the tangent and the inverse of the cosine and the inverse of the sine are these little -1 values right here. So tangent with the -1 is called the inverse tangent. So that's how we're going to write it here. The next thing I'm going to do is I'm going to bring down this trig function value. This was the value that I got when I took the angle or the tangent of some angle. That's what we're going to be finding. What angle was it? So we're going to type it in this order. The inverse tangent of this given trig function. And what we're going to end up with is the angle. This is going to be an approximate answer. So what your book does for these angle answers is it puts that symbol, which means approximately. I'm going to type it in. Second tangent. And now I'm going to type in this number. By the way, before we go any further, the other thing you always want to double check is that you are in the correct mode. In order to get the correct mode, you need to go to the mode key on your calculator, which is right here. And you want to arrow down and over if needed, and make sure your calculator is entered into degree mode. If it's radian like this, the radian mode will be highlighted. In order to put it in degree, hover over degree, I had to arrow to the right, and hit enter. And then once I move down, you'll see that degree is now highlighted, so I'm in the right mode. Clear to get out of here. And I'm going to now type in that number that is given here. And I can type it with my keyboard. You can do the same thing. Oh, I have to redo it. I don't have the inverse tangent. So let me clear this out. It should say second tangent. I must have accidentally hit enter, and then I'm going to type in that number. I always like to double check it before I hit enter just to kind of make sure you didn't make any typos. Press enter, and then we're going to round this answer off to 6 decimal places. So 81.168. And 168073. And I'm just going to leave it a 3 because it's got a 3 behind it. So 073. This time I'm going to find the angle when I'm given the sine and this trig function value. Remember, what we're doing here is we're finding the angle. So I'm looking for this theta. So that's what I'm going to start with. I'm going to use the given trig function. So I'm going to put that over here. And I'm using that to find it. And I'm not going to do the regular sine. I'm actually looking for the angle, so I'm going to find the inverse of the sine. Next thing I need to do is take this number, the trig function value, and I'm going to put it into the parenthesis. Now I'm ready to type this into the calculator. So again, just make sure you're in that degree mode, and you're going to type in the second, and the sine gives you the inverse sine, and then go ahead and type in this entire number. If you want to make sure that you didn't write any errors here, you can always look at the original number as you're typing it in. So I went ahead and hit enter, and I'm going to round my angle off to 6 decimal places. So count over 1, 2, 3, 4, 5, 6. So 57.997. And again, your book does this approximately. I don't know why it does it for these and not for the trig values, but that's just how it does it. 997 and 172. So this next one is not going to be a direct calculation because we don't have a cosecant button. We're still trying to find the angle though, so we're still looking for the missing angle, and we're still given the same information, the trig function value. So I'm going to write out what I'm looking for. I'm trying to find this angle. This time though, I have a problem because cosecant is not something that I can type into the calculator. So I'm going to refer you to page 29, and I want to think about what word goes with, or what trig function goes with cosecant. So you've got tangent and cotangent, that makes sense. Sine and cosecant go together. So you will actually be using the sine button because the sine is the same as 1 divided by the cosecant. And you can refer to page 29, you definitely should, to look at these reciprocal identities. So I'm going to be using the sine key in order to figure out the cosecant. I'm still going to do the inverse because the angle is what's missing. I don't have the angle, so that's what I'm trying to find using the inverse. I'm still going to bring down this trig function value, and I'm going to write it below. So it looks pretty similar so far. The one thing though that I have to do is I have to pay attention to the fact that over here it wasn't just sine and cosecant, it was 1 divided by cosecant. Somehow you have to let the calculator know that even though you are finding the inverse sine, what you're really doing here is you're finding ultimately a cosecant. In order to do that, what you have over here is 1 divided by the cosecant. Well, check this out. The cosecant is actually this answer right here. And that's this denominator, and that's this right here. So the only thing that I'm missing is the 1 divided by. So if I put the 1 divided by, that lets my calculator know that I'm really using the cosecant. So that's how you handle that. All right, go to the calculator, type in the inverse sine of 1 divided by, and use those numbers. So I'm going to go ahead and type it in. You type it into your calculator and we'll compare. I'm ready to hit enter. I just double checked it to make sure I typed in it right. I've got the 1 divided by here. And it's going to equal 46 point, and again, I'm going to round off to 6. So count 1, 2, 3, 4, 5, 6 decimal places over. So 46.173. Got to relook at it here. 173,582. Again, these all just happen to just round off. I don't see any so far that have rounded up. So 582 degrees. Okay, same idea. We're going to start with the angle. The angle is the theta. Here's another one where we can't use cotangent. There is no cotangent button. So again, I'm going to refer you to page 29, and the button that you will use instead is tangent. The tangent button is the button that you're going to press. Don't forget we're doing the inverse, so don't forget that. And the tangent is the same as 1 divided by cotangent. So I need to put the 1 divided by after I bring this down. So remember, I'm going to bring this guy down here, the trig function value. But what I have here is just this bottom part. This is just the cotangent. See, this is the cotangent. So I still need the 1 divided by, because remember, I'm actually typing the reciprocal identity. So this is a cotangent that I have the answer of. I'm typing in a tangent. So in order to let the calculator know that, I have to put in the 1 divided by using this reciprocal. Go ahead and type it into your calculator now. And just like the other ones, I'm going to round it off to 6 decimal places. This one also, I just kept the 9. The 4 does not round it up. So the last part of your assignment is going to be applying some of these angle ideas. And we're going to be looking at this thing known as grade resistance. When you are traveling up or down a hill on a highway, you experience this force due to gravity. This force is called the grade resistance and can be modeled by this equation. Force equals W times the sine of theta. Theta is the grade, so that's the angle. So you can see that it's a greater than 0, a positive number if it's going uphill, and it's a negative grade if you're going downhill. In this case, W is the weight of the automobile. So F is your grade resistance, W is the weight of the automobile, and then the angle depends on whether you're going uphill or downhill. So go ahead and copy down example 2, and we're going to write down the formula. And we're going to define each one of the variables in your notes. The first variable is F, and that is the force due to gravity, the grade resistance. The next is the W, that's the weight of the car. And finally, theta is, of course, the angle. So in this first example, we're going to go ahead and write out the formula. Again, pause as needed if you need to catch up on some of these words. I'm going to copy down the formula and I'm going to plug in what I see. A 2,400-pound car traveling on a negative 2.4 degree downhill grade. We're trying to find the grade resistance, and we're doing that to the nearest 100 pounds. Even though it doesn't say it, that would be the directions. Okay, so we've got a 2,400-pound car. The weight of the car is the W. It's traveling on a negative 2.4 degree grade. That's going to be our theta. I'm going to put it in parentheses so that it doesn't look like I am subtracting the 2.4. So I am ready to solve this. This is just going to be 2,400 times the sine of negative 2.4. As you're typing this in, 2,400 sine, the negative 2.4, you need to use the negative key at the bottom of your calculator, not the subtraction sign. It does make a difference. So 2,400 times the sine. Notice how I don't even have to put the multiply in there. The calculator knows. And I get negative 100 and some change. The directions for this question say to round to the nearest 100 pounds. So that means I'm looking at this one and looking behind it. See how these are zeros? That means my nearest 100 pounds would be negative 100. I don't need any of the other information, just negative 100. And that would be my weight the grade resistance, the force pressing on the car if I'm on this type of a hill that is 2.4 degrees. So just a slight hill. So take a look at this one. This time I have a heavier car, a car that's 3,000 pounds, and it's traveling uphill. It has a grade resistance of 150. So I'm going to plug those in the proper spots. 3,000 pound car. The grade resistance is 150, and I'm looking for the angle to the nearest tenth of a degree. What I need to do then is get the angle by itself, but the angle and the word sine go together. So what I need to do is I need to divide by what's next to sine theta. And I can even kind of highlight it so you can see what I mean. This is one term. This goes together like this. So what I'm going to do is I'm going to have to divide by what's by it. In that case, we're dividing by the 3,000. We need to get the 3,000 away from the sine of theta. Those divide out. So sine of theta equals, and I'm just going to do the 150 divided by 3,000. And it equals 0.05. This is exactly what we were doing at the beginning of this assignment when we were missing the angle. So if we are looking for this angle, the angle right here, theta, and we are trying to find the sine of some angle, we can use the inverse. All we have to do then is plug in what it equaled. So if we know what this equaled, we can do the inverse of it to find that angle itself. So we're going to take the inverse sine, so second sine of 0.05, not 0.5, it's 0.05, it does make a difference, and we get this big decimal. The directions though said round the angle to the nearest tenth of a degree. So then if we look at this number, the tenths place is one number after the decimal. So instead of 2.8, we're going to say 2.9 degrees. So this one is 2.9 degrees, and that's your theta. So this would be a 2.9 degree slope on the highway. Okay, this is your last one. And you can see that we have a degree and we have a grade resistance. So plug those in as needed. 3 degree downhill grade, that means we're putting the 3 degrees, the negative 3 degrees here. That's part of the sine. We also know the grade resistance, that's your force, 145 degrees. And we're looking for the weight of the car to the nearest 100 pounds. Okay, so what we're trying to do is we're trying to get the W by itself. And these are multiplied together. So again, think about this sine of -3 as a complete thing, like a unit. These are together. So if I want to get the W by itself, I'm going to have to divide by sine of -3. And what I do to one side, I'm going to have to do to the other. So again, you could take your finger, cover up the W, and you'll see that we need to divide by sine of -3 degrees. Why does that help you? Well, that divides them out over here, and you're just left with the W. I don't see any thetas, so I don't have to do any inverses. I'm just going to go to the calculator. So I'm going to type in my calculator, -145. Again, use the negative at the bottom of your screen, not the subtraction key. Divided by sine of -3. And the directions say nearest 100 pounds. Okay, so your answer is 2770.56 and so on. The directions, though, say round to the nearest 100 pounds. 2,700. I'm rounding here. Okay, so the question is, do you leave it 2,700 or do you round it to 2,800? look at the number behind it. Since it's a 5 or up, you need to round this up. So instead of 2,700, it would be 2,800. And the label on this is pounds. So this would be a 2,800 pound car if it had that much force with this angle. This is your assignment set for this lesson. Have a great day.